Welcome, Chemistry 1B, Unit 5, Video Example 8. This example is going to work with half-life. Now remember, anything to do with half-life implies a first-order reaction, okay? And therefore, we work with the equations for a first-order reaction. So in this example, we see that iodine isotope 131 is used as a metabolic tracer in hospitals. It says it has a half-life of 8.07 days. How long before the activity falls to 1% of the initial value? So we're trying to find a time, okay? We're trying to find the length of time before the activity of this radioactive isotope falls to 1% of the initial value. Now remember, guys, that if we're working with percentage, we can assume that we start off with 100. So 100 is the full amount, and it's going to drop to 1%. All right, so we need to remember that the first order integrated, well, not really integrated, but the first order reaction can be written as you see it here. N implies the concentration at the end of the process. N0, this one here, implies the concentration at the start of the process, and obviously K is the rate constant and T is the time. Now, in order to get this into a workable form, we can take the natural logarithm, and we end up with what you would recognize as the first order integrated rate law. So here you have, this would be ln n is equal to ln n0 minus kt. Okay, so you should recognize that as a first order integrated rate law. So let me just finish writing that. Okay, now we can then rearrange this to get the answer or for the time. Okay, so we can then say, all right, we've got ln n over n0 is equal to negative kt. But now we can then substitute for k, remembering that it's a first order process where we can have t half equal to 0.693 over k. Okay, remember that's a real thing for first order reactions, where 0.693 is actually the natural log of 2. Okay, so that's where we get this expression here. Okay, and so we end up with this where we have we can substitute for k, and we can then solve for t. All right, so we then see that we come to this expression here, where t is equal to negative t half multiplied by the natural log of n over n0 divided by ln 2. Remember, ln 2 is 0.693. Okay, if you're getting confused with that. Okay, now we can simply plug in the values. So the t half, we were told up here, is 8.07 days. So that's what we install here. All right. The concentration at N0 is 100. N0 is where we start. Okay, remember it says 1%. So N0 is equal to 100. Doesn't matter, just arbitrary units. And then N is equal to 1, because that's in terms of percentage. Okay, so we start with 100%, and then when it falls to 1%. Okay, so we've got natural log of N over N0. So we've got 1 over 100 divided by ln 2. Remember, ln 2 is 0.693, and we end up with an answer of 53.6 days.